quantum computing isn't a far-off theory anymore, it's here. For years, quantum computing was something we read about in science fiction novels and academic papers. It was a tantalizing possibility that seemed light years away. But now, quantum computing has become a tangible reality, shaking the very foundations of technology. And China just took the lead. And now, China has surged ahead of everyone else, taking a commanding lead in the race to master quantum computing, a field once considered too advanced and theoretical for practical use. For decades, quantum computing has existed at the edge of science fiction. For decades, the idea of quantum computing was like a dream that belonged to the realm of science fiction, something we could only speculate about in movies and theoretical research. A tantalizing possibility that, if achieved, could reshape technology, security, and global power. But if it became a reality, it promised to completely revolutionize not just technology, but also global security and the balance of world power. The implications were enormous, touching every aspect of our digital and physical worlds. The idea was simple, a machine that could process information at an exponential speed, solving problems that would stump the most powerful classical supercomputers. The fundamental idea behind quantum computing was simple but mind-blowing, a machine capable of processing data at a speed exponentially faster than any conventional supercomputer, solving problems that would leave even the most advanced classical machines in the dust. In 2019, Google's Sycamore processor shocked the world by performing a calculation in 200 seconds that was estimated to take a classical computer 10,000 years. In 2019, Google made headlines when their Sycamore processor completed a calculation in just 200 seconds, something that would have taken a classical supercomputer 10,000 years to accomplish. It was a stunning demonstration of quantum computing's power. But just as the world was beginning to grasp that achievement, China arrived with a bigger claim. Just as the world was coming to terms with Google's revolutionary achievement, China entered the scene, with an even more astonishing claim that would completely change the narrative. One that has now rewritten the quantum landscape. This new development wasn't just a small leap, it was a game changer, a breakthrough that completely redefined the possibilities and potential of quantum computing. Their Jiuzhang quantum computer didn't just match Google's milestone, it obliterated it. China's Jiuzhang quantum computer didn't simply match the feat achieved by Google, it surpassed it by an enormous margin, pushing the boundaries of what we thought was possible in the quantum realm. The calculation, a problem known as boson sampling, was a complex mathematical challenge simulating the behavior of photons in an optical network. The task it solved was known as boson sampling, a highly complex mathematical problem that simulates the behavior of photons traveling through an optical network, a problem so intricate that it had never been solved by a classical computer. In practical terms, it doesn't yet crack encryption, cure diseases, or revolutionize AI. While this achievement is groundbreaking, it's important to note that it hasn't yet solved real-world problems like breaking encryption, curing diseases, or completely transforming artificial intelligence. But it proves something far bigger: quantum computers are no longer just a theory. What makes this breakthrough so monumental is that it proves something much more profound: quantum computers are no longer just theoretical constructs. They have transitioned into real, functioning systems that are capable of performing tasks beyond our wildest imaginations. And China might just be leading the charge. And in this race, China appears to be at the forefront, leading the charge into the new quantum age, where the rules of computing are being rewritten. Now, how big is this leap? So, just how significant is this leap in quantum computing? Let's break it down. Google's Sycamore solved a random circuit sampling problem in 200 seconds, initially believed to take 10,000 years on a supercomputer. Google's Sycamore made headlines by solving a random circuit sampling problem in just 200 seconds, a task that was initially thought to take 10,000 years for a supercomputer to complete. Later, corrected by IBM, it wasn't 10,000 years but just 2.5 days. However, IBM later corrected that estimation, revealing that the task would only have taken 2.5 days on a classical machine, not the 10,000 years initially thought. Jiuzhang, however, performed a far more complex task, one that would have taken 2.5 billion years on a classical machine. Jiuzhang, on the other hand, tackled a far more challenging task, one that would have taken a mind-boggling 2.5 billion years on a classical computer to solve. That's not just an improvement, that's an entirely different scale of computation. This isn't just a minor improvement over Sycamore's achievement, it's a leap into an entirely new scale of computational power, where tasks that were previously unimaginable are now within reach. For the first time, quantum supremacy isn't just a headline, it's a reality. This marks the first time in history that the concept of quantum supremacy, where quantum computers outperform classical computers in certain tasks, has transitioned from a theoretical concept to a concrete reality. So, what does this mean for the world? This breakthrough has far-reaching implications. What does it mean for the global landscape in terms of technology, security, and power? Is China now ahead of the West in quantum technology? Given China's stunning progress, the question arises, is China now ahead of the West in the race for quantum supremacy? Does this signal the start of a quantum arms race? Could this be the beginning of a new kind of arms race, not fought with missiles, but with quantum computers and algorithms? And perhaps most importantly, how soon before quantum computers start solving real-world problems? The most pressing question, how soon will quantum computers start solving problems that impact our daily lives, from cracking encryption to